Surprise! Saturday morning recording from my panic room here, where I am going to go over the homework. I'm doing this. I know I said that Wednesday was going to be the last video that I posted. I felt this was important to do for just considering the results that students earned on the homework. I saw a lot of problems, especially with interpretation. So I want to go through that. So two goals today. Go through every element of the regression table, identify where to look, but most importantly, I want to talk about phrasing and wording of the interpretation, and doing so in a way that builds understanding for what we're actually doing with the regression table. Because the biggest problem that I saw in the homework was not that people were looking in the wrong place. In fact, almost everybody identified the right number that needed to be reported as asked of you in each question of the homework. But I did see numerous problems with interpreting and wording what was actually happening and what you actually needed to be reporting. So that's the goal for today, is to really crystallize what you need to be doing if you see one of these again. And as it turns out, you will see one of these again. Okay, so let's get into it. Homework 6. Let's go through the equation here. The first problem that I saw was consistent mixing up of what is a dependent variable and what are your independent variables, of which there are multiple. So this is a multivariate regression equation. We have 7 total variables. Let's look at that first column. If you follow my cursor right here, we have 8 terms and 7 variables. Education, and then number of children, respondent's age, hours worked in the last week, sex, coded as male and female, married, coded as somebody is married or somebody is not currently married, full-time, someone is a full-time worker or someone is not a full-time worker, and then the constant, which is not actually a variable, it's just a term of the equation. So if we go through this, notice how this top variable, EDUC, that does not have a coefficient attached to it. So if we look now at these 2 columns next to each other, I have at the top here education, and then I have the following 6 variables starting with children and going through full-time. Notice how each of these 6 variables underneath the coefficient term here have an actual number attached to them. Let's go back and conceptualize what the equation we're operating with here. It looks like y equals b1x1 plus b2x2 plus b3x3 plus b4x4 plus b5x5 plus b6x6 plus a. There's only one y, and that's the first variable that you see here, okay? That is always the dependent variable of the equation. Why is the dependent variable? You can only ever have one, and in a regression table, it's always listed first because that's the variable, that's the outcome that is hypothesized to be affected by the other things that you've included here. And if you remember the equation I just gave you, b1x1 through b6x6, we have multiple independent variables. In this case, we have 6 of them: child's age, hours worked, sex, married, full-time. And then the very bottom, the constant, that is a, the y-intercept. So it's not appropriate to think of that as a variable, but it is something that is an important term of the equation. And you do have to interpret it and understand what it is. So I saw a lot of students do the following. A 1-unit increase in education is associated with a B-unit change in number of children. That's flip-flopping what's going on here. It's not that you do not have an equation here where changes in education are affecting children, age, hours worked, sex, so on and so forth. No. The thing that is always being affected is the dependent variable. It does not have a coefficient attached to it because the coefficient reported for these 6 independent variables are understood as the change in Y, the change in years of education, assuming change in the 6 independent variables you have reported. Hopefully that makes sense. You do not want to interpret this as in effect, a change in education is affecting number of children and is affecting age and is affecting hours worked. No. Those 3 things, number of children you have, age, and hours worked. Those three things all have an independent effect upon the outcome of respondents' years of education. So if you read the word problem again, you will see that you are told in words that you have a regression equation that's predicting years of education. That's the dependent variable. And that is always the thing that is changing, assuming change in the independent variables. Another way to look at this is to just always identify in the regression output what is the first variable listed. It does not have a coefficient attached to it. The first variable listed is always the dependent variable, and the dependent variable is always the thing that is changing. Okay? So if we needed to interpret this, then let's go to that next coefficient in the column. Number of children. Is it significant? It is. Because the p-value is less than 0.05. And this was another problem that I did observe is establishing significance. You want to see a value that is less than 0.05. And if you see a number here of 0.000, that is understood to be less than 0.001. And if something is less than 0.001, it is also by extension and by logic less than 0.05. Okay? So it is a significant variable here. The sign is negative, meaning that an increase in number of children is associated with a decrease in years of education. So here's my interpretation. A 1 unit increase in number of children is associated with a 0.67 unit decrease in years of education, net of other effects. So the three problems that I observed in people's reporting of this is, one, the most common was to say a 1 unit increase in education is associated with a 0.67 unit decrease in a number of children. That's flip-flopping the ordering that you need. No, it's always, you always start with these independent variables and finish with its effect on the dependent variable. Some people forgot net of other effects. In a multivariate equation, you must demonstrate that this is assuming the other 5 are held at their means. So let me put this as clearly as I can. If you have a significant coefficient inside a multivariate equation, you must finish with net of other effects. And then the third major problem was people looked at that and sometimes said this was a non-significant coefficient. No. Anything that is 0.000 is always less than 0.05. And if it's less than 0.05, it is always a significant coefficient. Okay? So I'll repeat my interpretation one more time here. A 1 unit increase in number of children is associated with a 0.67 unit decrease in years of education, net of other effects. Pause for a second to let that sink in. Okay. All right, what else? So I'm going to go through all of the variables here, whether or not it was required on the homework to give some extra practice here. So let's just go to x2 in this equation. That's the second independent variable, and that is age. Okay, so following the same logic here, a 3-step process. Is it significant? Yes, its p-value is less than 0.05. So yes. It is a significant coefficient. What's the direction? The fact that it's a positive number. The coefficient is 0.0436811. That's a positive number. Therefore, it is an increase. So, knowing that I have a significant positive coefficient, A 1 unit increase in respondents' age is associated with a 0.044 unit increase in respondents' years of education, net of other effects. Again, I think too many people understood this to be an increase in education altering the number of the age of the respondents, and no, the relationship is flowing in that opposite direction. Age's effect on education. The older you are, the more years of education you tend to have on average, and net of other effects. So notice how in interpreting here, this is similar in a logical perspective to what we did interpreting number of children. But I changed the first variable reported. And what I mean by that is instead of saying a 1 unit increase in children, now I just said a 1 unit increase in respondents' age. And the second half of this interpretation, the dependent variable, that always stays the same. So once you know the dependent variable, you are always dealing with an increase or decrease or no change at all in that dependent variable. In this case, it's years of education. So that second variable will always be education within the interpretation sentence. Now, moving on to HRS 1, which you were told in the coding document is hours worked. Same thing. I'm going to do the same 3 processes here. The p-value is less than 0.05. I saw numerous students here correctly identify the child's variable as significant because of its 0.000 p-value. But when it came to identifying the significance of hours 1, people saw that there were numbers there and not just zeros, and sometimes interpreted that as a non-significant finding. That's not correct. 0.024 is less than 0.05. Therefore, this is a significant coefficient. What's its direction? That's step 2 here. Because this is a positive number in the coefficient column, it's a positive relationship. So a 1 unit increase in hours worked, again, I'm going with X3 here, a 1 unit increase in hours worked per week is associated with a 0.019 unit increase in years of education, net of other effects. Notice how for the 3rd time now, we have finished with an increase in years of education, or a change in years of education. That's the thing that's being affected by all of these independent variables. I can have as many independent variables as I like, but one and only one dependent variable. Okay, so those 3, all 3 of my independent variables measured at the interval level are significant. 2 are positive, 1 is negative. All are referring to changes in years of education. So that's my key thing here. I need everyone to understand the independent variable changes, but the dependent variable does not ever change. Now, when it comes to interpreting my categorical variables, remember, reference group versus group of interest. So you were told here that males and females were the 2 coded outcomes for this variable of sex 1. Okay, so that's the first thing I have to know here. It just changes the wording of my interpretation, but not really what I'm trying to do. I'm still trying to figure out about differences in educational attainment. So you were told that this variable is coded in the following way. Males equals 0 and females equals 1. That's the way that this particular variable was coded. So looking at the p-value here, is it significant? Once again, yes, it is, because a p-value of 0.039 is less than 0.05. Narrowly, but it is less. So this is significant, and the directional sign is negative here. When I am dealing with this categorical or this dummy variable that I need to interpret within a regression, that coefficient that you see there, negative 0.4020041, that's the effect on educational attainment of being female as compared to being male. How do I know what's being referred to what? Group 1 is always compared to group 0. Group 0 is the reference group. So the female coefficient is compared to males. Some of you wrote down that males have fewer, a lower level of educational attainment than females here, and that's not actually what's happening. On average, here's my interpretation. On average, females possess 0.402 fewer years of education than males, net of other effects. It is the effect of being female as compared to being male. So the fact that the coefficient here has a negative sign attached to it, that right there tells me right off the bat that group 1 has lower levels of the dependent variable, lower levels of years of education as compared to the reference group of males. Okay? So when you're doing this, first, identify what is group 1 and lead your interpretation by comparing group 1 to group 0. Make sense? And knowing how to do that is going to help us on the following two coefficients. Even though there's a bit of a trick, like I didn't ask you to interpret married or full-time. I wanted them thrown in the model though. So married. Non-married equals 0. Those who are not currently married equals 0. Those that are currently married equals 1. So I know that married, this coefficient is the effect of being married as compared to non-married individuals. But first, let's look at our p-value. The actual correct interpretation of this is married respondents do not have significantly different educational attainment than non-married respondents. So I still led with the group coded as 1. I still led with the group that's compared to the reference group. But how do I know this is not a significant predictor of years of education? Notice how that p-value, 0.281, I will ask you, is that number less than 0.05? No, it's not. It's significantly greater than 0.05. So anytime you see a p-value above 0.05, the correct interpretation is that this variable is not a significant predictor of educational or of the dependent variable. So I'll give you two ways that you can appropriately interpret non-significant coefficients. If I'm dealing with this type of categorical predictor, I can say, as I have here, married respondents do not have significantly different educational attainment than non-married respondents. Or it would be equally correct to say sex is not a significant predictor of educational attainment. One is not better than the other. They both tell me the exact same thing, and you can use whichever wording there makes the most sense to you. And I hope you can see how saying married respondents are not significantly different from non-married respondents is functionally the exact same thing as saying marital status is not a significant predictor of educational attainment. So because the p-value is greater than 0.05, I don't have to interpret the number here. But if you want the extra practice, if we just pretend that that p-value was pointing in a significant direction, how would we interpret this? Well, what's my reference group? My reference group is non-married individuals as coded as 0. So knowing that, I would say, and again, this is only assuming it's a significant variable, I would say married respondents possess 0.215 years of years of education more. Actually, let me start that over. Married respondents, on average, hold 0.214 years greater educational attainment than non-married respondents. Net of other effects. I always lead with the group coded as 1 and compare it to the reference group. And that is also going to be something we can apply in theory to the final coefficient here, which is for full-time workers. I had this coded, so I just decided to throw it in and see what would happen. Again, what's the correct interpretation here? Is my p-value of 0.707, is that value greater than 0.05? It is not. Therefore, full-time workers do not have significantly different educational attainment than non-full-time workers. So I took the group coded as 1 and I compared it to the reference group, and I said that it was not a significant difference. And voila, that is a beautiful, perfect interpretation that would earn you full credit. Do you want to pretend that it is significant though? Try your hand at interpreting it, assuming a significant p-value. Here's what I would say. On average, full-time workers hold 0.123 fewer years of education than non-full-time workers, net of other effects. Why did I say fewer? Very simple. I'm looking at a negative coefficient here. A positive coefficient in this type of categorical variable shows that group 1 has greater average levels of the outcome than group 0. A negative coefficient, group 1 has higher average, or lower levels of the dependent variable than the group coded as 0. Finally, you were asked to identify the model's y-intercept. You don't have to worry about the p-value here. And in fact, just the way that the y-intercept is often calculated, the y-intercept is very likely to be significant, although you don't have to interpret it. Just know that it very often is. But the p-value does not mean what you think it means if you're taking the logic from the 6 x's above it. The constant underscore cons is the model's y-intercept. That is the value of y when all x's are equal to 0. And this was a problem that I saw consistently. A lot of people reported the y-intercept to be the level of education, the level of educational attainment when child's equals 0 or when age equals 0 or whatever. No. It's assuming all of these are equal to 0. So statistically, when child's age, hours 1, sex 1, married, and full-time equals 0, then the baseline level of educational attainment is 12.55. Another way to put this, and perhaps more simply, you don't want to just say when child's equals 0, education equals 12.55. No. You either list all of your variables or you simply say when all independent variables are equal to 0, respondents possess an average of 12.55 years of education. Now, if I was going to publish off of this, I would actually do something a little different here because I have a variable where it doesn't make much sense to report a y-intercept for, and that's age. Like when age equals 0, that's like, it's not particularly helpful to conceptualize age as being 0 when the minimum age in this data set is 18. But statistically, I would have to tell the model to do something else then. I'd have to throw a couple bells and whistles on that. It's not terribly difficult, but for your purposes, this is assuming that all x's are equal to 0, and not enough of you did that. Too many of you reported just one x equaling 0. So the key thing to keep in mind here, when all x's equal 0. And that leaves just one final question to answer. I asked you to identify and interpret the model's y-intercept. Wait, I made a mistake. It's too late to start over. The model's r squared. We just did the y-intercept. So r squared is the total amount of variation in the dependent variable explained by change in the collection of independent variables that you have included. So my r squared is 0.0373 here. Think of that as a percentage. So you will want to move the decimal place 2 spots. And this is now understood as 3.73%. When child's age, hours worked, sex, marital status, and full-time status are considered, it explains 3.73% of all variation in years of education, because I am focusing on how all these factors in the aggregate affect the dependent variables. Okay, so the key thing to keep in mind here, multiple x's, but only ever one y. So let me just reiterate the 3 big problems that I saw. I saw people mixing up what is y and what are your x's. This top value here for education, the top term there, that is always the dependent variable. I saw people mixing up the comparisons in these categorical variables. The group coded as 0 is always the reference group. And I saw people mess up the p-values here. If this is below 0.05, it is significant. If it is above 0.05, it is not significant. So feel free to reach out. I'm more than happy to get on the phone with you or answer email questions if this is still confusing and concerning to you. Otherwise, I'm here to talk about anything you want to talk about. Good luck, Godspeed. Get those finals in by noon on Friday. Thank you very much, and you guys take care of yourselves. Happy weekend.